Math 2, Module 2, Practice Problems 2.1 through 2.7. This is the first page worth of solutions, so questions 1 through 5. Graphing question number 1. F of x equals the quantity x minus 2 squared plus 1. Well, noticing that this quadratic equation is in vertex form, the vertex would be at 2, 1. So I could plot that point, 2, 1. Axis of symmetry would go right through that point, a vertical line. So that would be x equals 2. Notice this is the x coordinate of the vertex. This is positive, so my graph's going to open up, making their 0 x-intercepts in the function b have a minimum value. Graphing these points, there's several different ways you can get these points. I always choose my vertex to be the middle, so 2, 1. I'm going to use a table this time and get a couple points behind, like to the left of the vertex and to the right of the vertex. I could substitute these problems in and solve if I did that. 3 minus 2 squared plus 1 would be 1 squared plus 1, which is 2. I know because of my axis of symmetry, if the point's at 3, 2, then the point is also at 1, 2. 4 minus 2 squared plus 1 would give me 2 squared is 4, plus 1 is 5. And I have the shape of my quadratic. Letter B, hopefully you change this. This should be a plus 7 instead of a plus 11. In standard form, it is tougher to find the vertex in the axis of symmetry, so I'm going to go through the process of completing the square to convert this to vertex form. So not a perfect square because half of 6 is 3 and that squared would be 9. So let's make this a perfect square. X plus 6x. Still have my plus 7. Again, half of 6 is 3. 3 squared is 9, so to make that a perfect square, that'd have to be plus 9. If I add 9 within here, I have to subtract it on the outside. So then writing this as a perfect square, again, half of 6 is 3, so this is x plus 3 squared, and 7 minus 9 is a minus 2. X plus 3 squared minus 2 would give me a vertex at, since this is plus 3, my x-coordinate's the opposite, so that's a negative 3, and minus 2 would be still a negative 2, making my axis of symmetry at x equals negative 3. So negative 3, 2, negative 2. This is positive, so it's going to open up. This time, I'm just going to use the fact that this has a leading coefficient of 1. I know my vertex is at negative 3, negative 2, and follow my quadratic pattern. 1 squared is 1, so up 1 over 1 in both ways. So at negative 2, that's negative 1, negative 4, negative 1, and then from my vertex again, 2 squared is 4, so up 4 and over 2. For negative 1, 2, and negative 5, 2, and I get a pretty good shape of my quadratic function. Once again, this is a parabola that opens up. This has 2 x-intercepts, 1, 2, and this would be a minimum value. Two through 5 are all asking us to find a value that makes the expression a perfect square trinomial and write the trinomial as a product of 2 factors. So if I'm given the back term, the final term, the c, the constant, I would look to take the square root of that. Square root of 64 is 8. So that's going to make my 2 factors, x plus 8 times x plus 8, or you could write that as x plus 8 quantity squared. Either way I'm good. To get my middle term then, I take this 8 times 2 is 16, so this middle term is going to be 16x. Same process here, square root of 9 is 3, so this would be x plus 3 times x plus 3, or I'm going to write it as x plus 3 squared. 3 times 2 is 6. This middle term is my 6x. 4 and 5 switch. They start giving me that b term, that middle term. So I'm going to take half of that. Half of 14 is 7. So this would be x plus 7 squared, quantity squared. 7 squared is 49. So that would be my c constant. In number 5, half of 24 is 12. So that is x plus 12 squared. 12 squared is 144, and that would be my C.